Here we have a multi-domain network deployment with campus and data center devices. Cloudvision is regularly used by our customers to save time when orchestrating changes across the network, including device software upgrades. We are going to use Cloudvision Change Control to upgrade the devices in Data Center 1. They are currently running EOS 4.27.4m and Streaming Telemetry Agent 1.19.4. There are some active traffic flows running across our network, and we are viewing one flow to understand the traffic path between a host in the DC to a host in the campus. We will monitor this flow as we step through the network-wide upgrade of the data center. An image bundle is created with the new EOS release and Streaming Telemetry Agent. Devices are grouped into containers, which allow us to assign a common set of config and software images to all devices within that container. Assigning the image bundle to the DC1 container results in all devices within that container inheriting the image bundle assignment. A task is created for each device, and we will add it to a change control to execute. Optionally, give the change control a meaningful name and assign the selected task to the change control. The default arrangement of the tasks is in series, and we can see the upgrade image task with a power icon indicating a reload is required. Introduced in the 2022.2.0 release of Cloudvision, we have the option to preload the images onto the devices. This allows us to prepare for our change ahead of the maintenance window and automates the copying of the image files across our network. We choose how many parallel downloads we want to enable and proceed with a new change control solely for the image copy function. We review and approve this new change control, and Cloudvision proceeds to copy the new image files to all devices in the change control. Now, when we choose to execute our upgrade tasks, the files will already be present on the devices, and we've saved time within our maintenance window. Now we can proceed back into our change control and use Cloudvision to orchestrate how we want the devices to be upgraded. A change control allows you to move tasks around, apply actions, and specify whether tasks are executed in series or in parallel. To help automate this orchestration, we can apply a change control template. We have a custom-built template ready for our DC upgrade. The definition of this template will be detailed in a subsequent video. When the template is assigned, it evaluates the actions defined within the template against the tasks available. We can further modify the resulting workflow as required, for example, ordering single tasks or entire groups of tasks. Our upgrade template here has grouped the spine switches and automatically added some actions. The first spine will enter maintenance mode, which will gracefully drain the traffic away from the device before proceeding with the upgrade. Once upgraded, the device will exit maintenance mode and then run a custom action which will compare the BGP metrics before and after the change as a health check. With the first spine switch upgraded, the change will proceed to the next spine switch, again maintaining an active traffic path across our leaf spine network. After the spine switches are upgraded, the change control will proceed to leaf switches. First, our B-side switches. These will all be running parallel. First, taking a snapshot which we've defined to capture a record of some network state. Check the status of MLAG, ensuring the redundant path is available, then proceeding with the upgrade. When the device is back, we'll check MLAG again before taking a post-upgrade snapshot for our records. Now with the traffic path through B back in service, the change will proceed to upgrade the A-side leaf switches, taking a similar workflow of snapshot and MLAG checks. The result will be an automated network-wide upgrade with minimal to zero network impact. As the change control executes, we can monitor the real-time state streaming into Cloudvision from the network. This offers the user with unparalleled visibility into the current state of the network as changes are deployed. With this real-time feedback, the impact of the change is immediately visible to the user. Initially, we'll filter out the leaf switches to focus in on the spine switches. Reviewing the change once more before proceeding, we confirm that the design software image bundle is our intended upgrade. Then we approve and execute immediately. We could instead schedule to execute at a certain time, but we'll proceed for now. Let's check our traffic flow prior to Spine 1 entering maintenance mode. Maintenance mode We'll use BGP communities to signal to the leaf switches that it is going out of service. This allows the active flows to complete and new flows to exclude that path from the ECMP hashing algorithm from the leaf switches. Our flow from DC host to the campus host is now utilizing the other available path through spine 2. With the traffic safely using an alternate path, the spine switch proceeds with an EOS upgrade, which in this case includes a reload of the switch. With the switch back online, it exits maintenance mode, this time signaling to the leaf switches that it is back in service and available for traffic. Our traffic flows hash to the spine 1 and resume on that path. Now spine 2 enters maintenance mode, and any traffic that was using that path would be drained away. With the spine switches upgraded, we can proceed with the leaf switches, first starting with the B-side switches. Cloudvision takes a snapshot for our records, checks the health of MLAG between the leaf switches, then proceeds with the upgrade. MLAG ISSU is leveraged here to maintain a redundant path available for traffic flows of dual home devices. The B-side leaf switches reload as part of this upgrade, and when they return, enter an MLAG reload check phase. This phase ensures the downstream and upstream paths are active and available before allowing traffic to return to that path. The timers for the reload delay are configurable. With the upgrade complete, we take our post-upgrade snapshot for our records and continue with the A-side switches. The same process is applied, taking our custom snapshots, maintaining an active path with MLAG ISSU, then collecting all post-upgrade snapshots. Whether this is for a small network or large network, the execution of these tasks would be time-consuming and intensive. Cloudvision is not only helping the operator automate the upgrade of devices, but allow for customized collection of network state for change control documentation purposes, and to orchestrate a network-wide rolling hitless upgrade. Meanwhile, maintaining visibility through real-time streaming telemetry to immediately recognize when state changes and even apply action scripts to react to those changes.